Okay, geometry, we are in chapter 1, section 5, and you get to experience a live lesson with the class of 2015 today. And we're using formulas in geometry. Say hello, class.
Hello.
Okay. Oh, listen to how beautiful. It's like a musical sound. And so start with a warm-up and come back and check your work. 12 squared is
144.
7.6 squared is
57.76.
square root of 64 is
8.
And now this is being asked to, you're supposed to round to the nearest hundred, so they're asking for a decimal answer. If they didn't say it that way, you could just simplify the radical. Remember? You would take any perfect square factors out and you could leave something behind. But I know you may have used a calculator, but what is the closest perfect square to 54? 49. So this is 7 point something close to 7, right? So less than 7.5 probably, since it's closer to 49. And what is your answer?
7.35.
Okay. And 3 squared pi, in terms of pi, how would you say that?
9 pi.
9 pi. But then when we actually multiply by pi, you get?
28.27.
Good. And remember to do that estimate before you use the calculator. So right now, 3 times pi, pi is approximately 3.14. So what would your estimate be just for 3 pi?
9.42.
Okay, so you're thinking about 9.5. And 9.5 squared would be not quite 10 squared, right? So what's your estimate? Don't tell me the exact answer. You already did. So it would be something less than 100, something greater than 81 for sure. It's closer to 100, so in the 90s, right? And what do you get when you do it?
88.83.
Oh, I said in the 90s and I wasn't right. 9 point... So it's lower, it's a little lower than 9.5, right? You said 9.4, that makes sense. Okay, good. You may use your calculator in geometry, but do estimate before you do. So today we're going to talk about using formulas in geometry, and these formulas we're using, you know all about already. What do we call it when you're adding the sides of a figure? And notice we're talking linear units. Linear means in a line, right? Just walking around something. So a unit might be inches. Not square, just inches, right? You're measuring around something. So you could literally cut it apart and lay it out in a big long line. So what do we call, what is it called when you're measuring something and you're finding the number of non-overlapping squares that will fit there?
Area.
Good. So whenever you find area, imagine you're laying squares across this thing. How many of the squares would fit? So here's our little formula box. And so we're looking at how to find the perimeter and area of these different shapes. So what is this first shape?
Rectangle.
Good. And so using the variables that they have used here, we have an L and a W. So Sarah, how would you use those variables to find the perimeter?
2W plus 2L.
Good. You could also write that using your distributive property, right? They both have a factor of 2. So you could write it as 2 times L plus W. Or you could write it as 2L plus 2W. And then Sarah, how about finding the area using these variables?
WL.
Or LW, either way. Good. And then when we're talking the next figure, what is it, Carly? This figure here.
Square.
How do you know it's a square? Those little, they called them tick marks earlier in this book, right? They all match. Notice with a rectangle, just the opposite sides have the same number of tick marks, which means the opposite sides are congruent. But in this square, we have every side. So that simplifies perimeter and area for us. Using S, Carly, how do you find the perimeter? And we put the number 4 first because it's a constant. Okay, we put the more constant terms first in multiplication products, right? And then how would you find the area? S squared, which is the same as length times width. It's just that the length and width are the same, right? As compared to a rectangle where the length and width may not be the same. Is a square a rectangle?
Yes.
Yes, it is. But not all rectangles are squares. Okay, and the final figure here is a
Triangle.
Okay, so using the letters that they've given us for the sides here, Sophia. Perimeter, good. And then the area. Good, so base times height over 2. It's my favorite way of writing it because it's a little shorter, I think, than writing 1/2 of base height. But it's equivalent, right? Good. How do we know which side of a triangle is the base?
It has the height, it has the dashed line for height going up from it, or
Is there always a dashed line
there's
for height?
always a dashed line, sometimes it's a right triangle.
Or it could be a right triangle where a side is that given height, right? Any side actually could be the base. Any side. You just have to find the height carefully once you've chosen the side that is the base. And so in many cases, you don't have a lot of choices, or, they give you a height, so that kind of determines the base you're going to use. Is height always up and down?
No.
No. It's, how would you describe height? Who can describe it? It's a segment that forms a what?
A right angle.
It has to form a right angle, good. From the base to the opposite vertex. It could be inside or outside of the triangle. So here was the right triangle, so I guess we should say it may be inside, outside, or on the triangle. Why don't you add that? Or on, over here. This height is perpendicular to this base. Actually, could we switch these letters?
Yeah.
Yeah, we could call this side the base and this side the height. Height, again, does not have to be up and down. It simply must be perpendicular to one side and go to the opposite vertex. So in this case, we have an interior height because they've chosen this to be the base, right? And then in this case, you see an exterior height. Exterior from this base, okay? What's tricky about this when finding area, Lauren?
Some people will, sometimes they have the whole
Measurement
measurement
for this?
using the dashed area, and that will confuse people.
Right, you don't want to use that. You simply want to use this base here and multiply by this height. Even though it is looking like it's outside, it is the height of that triangle given this base, okay? Okay, let's find perimeter and area of these figures. So go ahead and pause, come back when you're ready. We want to show our reasoning, and we're getting ready to do longer proofs and things that are very detail-oriented in geometry. So when you're asked to find the perimeter, begin with the formula. Perimeter of this equals, we already said it, it's a rectangle, so the perimeter equals, so start with that formula, and then notice we can come down and substitute. So it would be 2 times,
4 plus 2.
it doesn't matter which one, where you entered it. Either of them could be the length, either of them could be the width. And then we simplify, right? And did you all get 20? Good job. And area, what are we going to start with, Carly? Good. I like that. They say length times width, which is often used with rectangles and squares. More often with rectangles. And so what do you have? What's your area? Good. 24 inches square. Okay, and now with a triangle. Start with your formula, substitute, and simplify. We have unknowns in the expressions for 2 sides, so we will end up with unknowns in our answer, right? And so how are you doing it, Sophia? Okay, so probably start with the formula, and then she substituted this stuff, and then what did you end up with? Good, 6x plus 10, good. And then area, Michaela,
I started with pH over 2,
good?
and then I plugged it in with 6x plus 24 on the top.
Okay, so she distributed 6x plus 24, she says,
And then
over 2.
So it equals 3x plus 4.
Good job, she distributed her division. Now you could just take half of 6, which is 3, and 3x plus 12 distribute. So because it's all multiplication in the numerator, I'm considering the red to be the numerator, right? Then you may cancel a little factor of 2 here, okay? And finally, how about a square? Sarah, how about a square? What will you start with as far as the formula goes? Do you not have that?
And then we have a circle.
You have a circle? Squeeze this in if your notes don't have this, but find the area of a square. How do you find the perimeter, Sarah?
You
It's a
do
square.
3.5 times 4.
Good. Or we would start with that formula, right? And then she says 3.5 times 4. And can you do that in your head?
I doubt it.
4 times 3 is,
12.
and 4 times a half.
2.
So
12.2.
actually, that's 2 wholes. When you have 4 halves, you have 2 wholes. So you have 12 plus 2, which is
14.
14. Good, 14 inches. And then, Lauren, the area of a square.
Area of a square is the side squared, so the area is 3.5 squared.
And that would be approximately what?
It's going to be between 9 and 16.
And probably halfway between 9 and 16. So how far apart are 9 and 16?
5 and 7.
7 apart, so you're going to go 3.5 at least, probably, right? And 9 plus 3.5 is 12.5?
Yeah.
So what do you have? 12.25 is what she has on the calculator. Very good, so that's a good estimate. Okay. Do you have this in your notes, the Queen's quilt block?
Nope.
Okay, let's go to the circle. So what do you call a segment that passes through the center of a circle?
Radius.
And so I guess it would have to touch but 2 parts on the circle as well, right? And it's a diameter. And how about a segment with endpoints that are on the circle and at the center of a circle is a radius? Good. And the distance around an entire circle is? So if it wasn't a circle, we would call that what?
Area.
No, distance around. So perimeter, right. So here we have all those images. We have the little red one, which is the radius. The blue one is, oh, that's a center. Diameter is here. So this point here is a center point. And what are we talking? Oh, you know, I bet you this green thing, if we chop it, if we cut it and lay it out flat, is the circumference. So that's what this is showing you. If you take a circle and kind of cut it and lay it flat, circumference is that distance, which isn't actually straight, it's actually curved, but it could be measured in a linear way because you could lay it out flat. Okay, so do you remember the formula for the circumference of a circle? Do you remember that?
2 pi r or pi d.
Or pi d, which is my favorite one because it's shorter, right? But 2 pi r is often used on formula charts, so pi d is just so succinct. And the area of a circle, everyone, is pi r squared. Okay? Why is pi irrational, Lauren?
Because it's the circumference divided by the diameter and just goes on forever.
It goes on forever, and if you're irrational, you go on forever, so you do not terminate. And what's the other thing that must be true?
We can't predict it.
Not predictable, no pattern. They have not discovered any pattern in pi. So that's why it is irrational. The most famous irrational number, I guess. Pi is often approximated, though, at what? To the hundredths.
3.14.
And then the fraction,
22 over 7.
22 over 7. Those are often used. You may use your calculator in geometry, and there's a pi key, which is more precise than 3.14 because it takes it out to more digits. So use it when you're approximating, okay? Let's find the circumference and area of a circle with a radius of 8. Go ahead and start with your formula and substitute and find. Kayla, do you have the circumference?
16 pi or 50.26.
And they say round to the nearest tenth, so yours would match this, good, 50.3. And then area, Sophia? Pi r squared, good. So she has 64 pi, which is 201.1 centimeters squared. Excellent, good. And so try this lesson quiz, come back and check your work, and your assignment is there. And there are those answers. And when we have units, we definitely show them. And when we don't have units, we could use u and u squared as a reminder that we would put the units if we knew them. So there's your assignment, and good job.